In this media, you will learn about toxicity detectors. Toxicity detectors are used to determine the amount of toxic gases in a sample. The instrument consists of a sealed detector tube. To use this instrument, first the ends of the sealed tube are broken. Then, the detector tube is inserted into the instrument and the gas to be sampled gets absorbed into it. Now, the color of the gas in the tube changes as the result of the reaction between the toxic gas and the chemicals inside the tube. The color stain raises against the scale reading marked in the tube. This reading gives the amount of toxic gas in the sample in terms of parts per million, ppm. The detector tube has a specific shelf life stamped on it. It should be used before that date. Before inserting, the tube should be checked for any leakage. Thus, you have learned about toxicity detectors. In this media, you will learn about gas detection systems. One of the important codes of the IMO is to have gas detection system fixed in all ships. These systems must be connected to proper audible and visual alarms in the control room. The detection system must be located in the following areas: LNG tank room, electric motor rooms, LNG control rooms, unless classified as gas safe, enclosed spaces excepting spaces containing Type C LNG tanks, airlocks, vent hoods and gas to ER supply ducts. The gas detection heads should be subjected to regular testing and analysis. Sampling for each detector head should be done within an interval of 30 minutes. A normally functioning detector head activates the alarm when the vapor concentration reaches 30% LFL. At least 2 sets of portable gas detection equipment should always be readily available in the ships along with oxygen measuring equipment. All personnel in the ship should be given training on the usage of gas detection equipment along with the manufacturer's instructions. Thus, you have learned about gas detection systems. In this media, you will learn about oxygen analyzers. This is the diagram of an oxygen analyzer. In this oxygen analyzer, the oxygen diffuses through a Teflon layer. This diffused oxygen mixes up with the potassium chloride solution. This process of mixing activates the chemical cell. Current flows around the circuit when the switch is on. The current flow around the circuit can be checked through the deflection shown by the ammeter needle. Current flow increases on the increase of oxygen absorbed by the solution. The ammeter needle indicates the oxygen percentage in the atmosphere. This oxygen analyzer is insensitive and doesn't need a battery to operate. Other oxygen analyzers, such as polarographic and paramagnetic oxygen analyzers, are more sensitive and need batteries for operation. It is very risky to change the batteries in the gas dangerous zone, and it is not recommended. Oxygen analyzers have dual scales. Both of these scales have separate functions. This diagram shows the schematic diagram of a polarographic cell used in oxygen analyzers. In polarographic cell, the electrochemical reaction at the permeable membrane controls the current. A polarographic cell has a lifetime of about 6 months when operated consistently. Thus, you have learned about oxygen analyzers. In this media, you will learn about pressure and temperature monitoring. As per the IMO codes, Pressure must be monitored continuously throughout, in various components of the LNG system. Pressure switches are also fixed to various components, so that these switches act as alarm or shutdown units. As per the IMO codes, the temperature gauges should be fixed both at the bottom of the LNG tank and also near the top of the tank. The position of the gauge at the top of the tank should be below the highest allowable liquid level. The temperature gauge should be marked with the allowable lowest temperature level of the tank steel. In the case of Type A tanks carrying LNG below -55 degrees Celsius, the position of the temperature gauge differs. Here, the gauge is positioned either within the insulation or on the hull structure near the LNG tank. Thus, you have learned about pressure and temperature monitoring.